All right, so here we're supposed to recover the units of measure for the input and output variables of the quantity function for each rate of change function. Draw input-output diagrams for the rate of change function as well as the quantity function. So 2 says velocity in miles per hour is the rate of change of the distance driven during h hours. All right, so let's think about this. Well, what do you have? Well, we have input and we have output. So input, well, we're having h hours. We'll just write hours. Output is what? Well, it's in miles per hour. Okay. Now, if we think about this, our quantity function, output, is going to be what? Well, it's going to be miles per hour times hours, and that's going to be miles. Okay. So what we have here is for rate of change, we're plugging in hours. We have our rate of change, and we're coming out with what? Miles per hour. And that's what we said here. Now it says, okay, if we have our input, again, if it's hours, and now we have our quantity function, what's coming out here? Well, what's coming out is it says miles. Okay. All right, so let's think about the next one. The rate of change of a consumer demand for name brand motor oil is D prime million bottles per dollar when a bottle of motor oil sells for P dollars. All right, so input. Well, input looks like has to be that dollars. Output, well, that's going to be what? Million bottles per dollar. Okay, and our quantity function output, what's that going to be? Well, we're going to take that times that, and so it's going to be million bottles per dollar times dollars, and we get million bottles. Okay, so same thing here works. We have our input of dollars. We go through that rate of change, and what comes out is $1,000,000 per million bottles rather per dollar. Oops, wrote that backwards. All right, so million bottles per dollar. Then if we come over here, and what are we going to put in? Well, we're going to put in again dollars. Make a bigger dollar sign. And we're going to go our quantity function. And we're coming out with million bottles. Okay, so you kind of have to write out what you have, then you can draw your two functions after that. All right, here we have A and B are constants and X and T are variables. And these activities identify each notation as always representing a function of X, a function of T, or a number. All right, so 7, we have f prime of t, our first derivative, we have df dx, and we have f prime of 3. Well, this is going to be easy. If we're plugging in 3 into a number thing, we're always going to get a number out there, so we can start with that one. Now, with this one, we look at our denominator, and that's going to tell us our output. It's going to be a function representing x, so it's a function of x. And this one is a function of t. So those are pretty easy. Now, these get a little bit harder. So we're going to take and we're going to come out here and we're taking the integral first. So it's going to come out and we're going to get actually something of x. And so, but our final thing here says it's going to be a function of x here because that's the very last thing we do. We do the first things here and it's a function of t coming out, but we're plugging in a to x and we're going to get our t, but then we're going to take the dt dx and that's going to give us a function of x. And so what about this one? Well, this one, we're going to get out a function of x here, but then when we do dx dt, that means we're going to have a function of t. And here, what happens? Well, if we're having this one and we're going to get out basically a value, a to a, that's going to give us a number, and then we take the derivative of that, well, that's just going to give us a number, okay? So that's going to be our two different examples here. All right, so let's stop there and we'll come back for more.